Okay. Now, if you have completed the notes, write it in the notes itself. If you have not completed the notes, write it in the rough sheet. Okay? And you will answer on rotation. Krupa first, Rohit, Bharadwaj, Steve. Steve, if you cannot answer, you can type message. You can message. First, I will write the structural formula. Make 3 columns, common name and IUPAC name. Structural formula, common name, IUPAC.
And we should tell the answer.
Yes, yes. I told you how it is named. Common system, write both the alkyl groups according to the alphabetical order. If it is repeated, use the Greek prefix di. Put the word ether. IUPAC, they are alkoxy alkanes. Okay. Smaller group is taken along with the oxygen and it will be the derivative of the higher alkene. Okay. That much I had told. Now we are going to do the exercises. Then only you will understand it better. Okay. First we'll start with Krupa. Krupa will get the easiest first. CH3O CH3. Krupa, tell me the common name and IUPAC name.
Auntie, can you hear me?
Now I can hear you. Tell me.
And the common name, is it dimethyl ether?
Correct.
IUPAC,
IUPAC, alkoxy alkane.
methoxymethane,
Very good. Methoxymethane. All of you write it. Write all the examples. Methoxymethane. Second one, Rohit. CH3OC2H5. Rohit.
Ma'am, ethyl, methyl ether.
Very good. Ethyl, methyl ether and IUPAC name?
Methoxyethane.
Methoxyethane. See, ethyl, methyl both are there. Put it in the alphabetical order. E comes first. So, ethyl, methyl, ether. Very good. And oxygen should be taken along with the smaller groups. So, methoxyethane. Methoxyethane. Third, Bharadwaj. C2H5O, C2H5.
And the IUPAC is ethoxyethane.
Very good.
And I am not sure with the common name, but I'll just try it. Is it 2-ethyl ether?
You should, both the groups are same. What did we do here?
Dimethyl ether.
Say now.
Diethyl ether.
Correct. Diethyl. This is the ether we use in the lab. Whatever we use in the lab is diethyl ether. Ethoxyethane. Next, Steve.
Ma'am, could you switch on the light? It's not visible.
Yeah. It has become little cloudy. Now, just now it became very cloudy. Actually. Tell me, Steve. Steve, you cannot unmute and talk. You can message. For you, I give you that permission. Steve, are you trying? Steve?
Auntie, can you move 1 minute, Auntie? I'll just see the question.
CH3O C3H7. I'm not able to. Steve? Or is he messaging in the mobile? I don't know where he is messaging. Too much of. Okay, he's not able to answer. But write everything, Steve. Write everything. Then Rohit, Krupa only should answer this. He's not willing to answer.
Auntie, can I try, Auntie?
Yes, try.
Auntie,
Auntie, who, Auntie? Me or Kripa?
Krupa, you want to try?
I'll try, Auntie.
Ah, correct, Steve. You are saying correct. Tell me the common name. Tell me, Krupa.
Methyl propyl ether.
Ah,
IUPAC will be methoxypropane.
methoxypropane. Even Steve messaged. Very good. Both of you, very good. Methoxypropane. But common name, there is a little change, Krupa. Here, you have to mention whether it is N-propyl or isopropyl. Okay? So, you will write it as methyl N-propyl ether. Okay? Next, Rohit.
Ma'am, methyl isopropyl ether
Very good.
and methoxy.
Here also, methyl isopropyl ether correct.
Ma'am, and 2-methoxypropane.
Here also, you have to mention 1-methoxy. I forgot that. 2-methoxypropane. That will be 1. See, you have to number it like this. 1, 2, 3. So, on the second carbon atom, there is a methoxy group. Here, this will be direct. Okay. However, your number, you get this. But here, when it's a functional group is linked, this has to be given 1. So, it will be 1-methoxypropane. Here, it will be 2-methoxypropane. You just write along with me. Okay. So that I can erase it immediately. 2-methoxypropane.
Auntie, why is it not methoxy 2-methyl ethane
Which one? Which one?
in IUPAC name?
You have to choose the longest continuous chain. Root word will be that.
Okay, Auntie, and methoxy, we got it from CH3 and O.
Yes.
Okay, Auntie, and propane.
Propane. It's a
Okay, Auntie,
derivative
got
of
it.
propane. Okay. Next. Next is, who is next now?
Me, Auntie.
CH3, CH, Papa, Bharadwaj got a tougher one. CH3, CH, CH3, O, CH, CH3, CH3. If you can answer this, any one of you, open question, any one of you, if you can answer, excellent.
How, Auntie? I am only getting tougher ones.
Lucky man. You will learn, no, so well. Try. Common.
Auntie, is it diisopropyl ether? Something like
Diisopropyl ether. Very good. Now the problem is with the IUPAC name. Try. All of you try. If you can answer this, you have learned nomenclature of ether.
2-propoxypropane.
See, you are half right, almost right. See, this is 1, 2, 3. This is also 1, 2, 3. Correct? In such cases, you will write 2, this, and this is also 2.
2 comma 2 propoxy.
2 propoxy propane. Very good try, Krupa and Bharat. 2 on the second carbon atom, you have propoxy propane, but that is also not 1 propoxy, it is 2 propoxy. Very good.
Auntie, I didn't understand how that thing.
See,
The IUPAC name.
on the second carbon atom, they have propoxy.
Yes, Auntie.
Okay. Propoxy can be direct also, 1 propoxy also, like this.
Yes, Auntie.
But it is not. That I have to mention. It is 2 propoxy.
Okay, Auntie.
Okay.
Okay, auntie.
If you have understood this, next and all will be easier for you. I will erase the whatever I have written it in at the top, so that you can copy the lower ones. Now who will answer? Rohit. Rohit. Rohit, you are there?
Ma'am, methyl tertiary butyl ether.
Which will come first?
Tertiary butyl, ma'am.
Yes, very good. Tell me the IUPAC name. Tertiary butyl methyl ether. Very good, correct. Now tell me the IUPAC.
Auntie, but you said the lower group should be.
But it is B comes, no. Tertiary section
Okay.
come for the this one. Alphabetical order.
Okay, Auntie. So, since B is smaller than N, we are
B
writing
is
that.
one. That's try the IUPAC name, Rohit.
Auntie, here longest
2
chain
methyl,
only.
2 methoxy propane.
2. See, methoxy, methyl. Third word is Y there. Correct? So this will come first. 1, 2, 3. So it will be 2 methoxy.
2 methyl propane.
Meth is common, but after meth, this here it is O and here it is Y. So that will come first. Very good, Rohit. Excellent.
Auntie, I have a doubt, auntie. There is only 3 carbon auntie in the longest chain. Why are you putting tertiary butyl, auntie?
This is tertiary butyl group, no.
Okay.
Linked to carbon linked to 3 carbon atoms is tertiary butyl. We named this now tertiary butyl bromide, tertiary butyl.
Yes, yes.
So this is tertiary butyl.
Okay, auntie.
Auntie, in IUPAC, why are we not writing 2 comma 2 dimethyl propene?
Pardon, ma? Tell me.
In IUPAC name, why are we not writing 2 methoxy 2 comma 2 dimethyl propane?
If you take 1, 2, 3, this is the root word, there is only one substituent. Where there is 2, 2 dimethyl.
Okay, Auntie, got it.
Only one substituent. That's it. Next, Bharadwaj. Tell me, Bharadwaj.
Yes, auntie, 1 minute.
I think I can erase the lower ones also. Steve, you also try. If you cannot talk, you can message. No problem. Next one you try.
Auntie,
Auntie, can I try?
Wait. But it's Bharadwaj now, no?
Yes, auntie.
At least you can say the common name Bharadwaj. It's easy.
Auntie, there are two
Ah.
two
This is
tertiary butyl
so
sorry
ah
ditertiary butyl
correct. Ditertiary butyl ether.
ether.
Tell me the IUPAC name. Properly think and tell me.
Auntie, will it come propoxy?
Okay. See, I will number it. Now tell me.
2 propoxy 2 methyl propane.
Okay. Now tell me.
2 comma 2 uh,
See, you put first put two. This two. And
yes, auntie.
or this two. Anything. Both are same.
Okay.
This. Open a bracket. Because this is a complex
Yes, auntie.
event.
Okay.
Now, this is what
2-methyl propyl.
2-methyl 2-propoxy. Okay? 2-methyl 2-propoxy. Okay? Now, again, on the second, you have one more methyl. So, 2-methyl 2-propoxy methyl propane. You need not mention again 2 there. It's understood. On the second, you have 2-methyl 2-propoxy and this is methyl propane. It is actually basically methyl propane. Okay.
Auntie, it's confusing. Auntie, can you explain again?
This is little confusing only. See, if it was, I will tell you. Like this, Krupa. If this was like this. Okay? If it was like this, then this will be 2-propoxy, correct?
Yes, Auntie.
2 bracket 2-propoxy methyl propane. Correct? Now you have one more methyl here. So this becomes 2-methyl 2-propoxy. What happened, Bharadwaj? What happened? Here he is calling. There is some issue, I think. Hello? Okay, when it comes back, we join. Everything depends on technology, so much on technology. Understood, Krupa?
Auntie, how 2-propoxy came?
See, if it was only this, if it was only like this, okay? So, see, if it was this, tell me what will be this now? 1, 2, 3. This will be on the second carbon atom 1-propoxy, correct? Krupa, you are able to see this?
Yes, auntie.
So, see, if this was the compound, on the second carbon atom, it was 1 propoxy.
Yes, auntie.
Now, this is not 1 propoxy, it is 2 propoxy. On the second only that oxygen is there. Correct?
Yes, auntie.
So, now this compound has got methyl also on second. Methyl group, this methyl group on second.
Yes, auntie.
Whole thing becomes now 2-methyl 2-propoxy. On the second only oxygen is there.
Okay, auntie, got it.
So it is 2-methyl 2-propoxy. Methyl, this methyl propane. Okay. Now, Steve, you just type only, no problem. Easy only, man. You can aram say this. I'll give you easier one. There is no common name for this. You can just give the IUPAC name. Steve, you can message, no problem. See, Steve, you are able to understand this or no? You are able to talk, Steve? No. You are able to. No, it is not glycol. See, this is glycol, man. Glycol, if you write, then it will be ethane 1,2-diol. That will be the IUPAC name because that's the functional group. I will tell you like this. Because methoxy comes as prefix, what will be the name of this?
Ma'am,
Ah,
is it 1,2-dimethoxy-ethane?
that's what I was just I just trying to explain to him. What will be the name of this? 1,2-dichloroethane. But if you write OH, that will become the suffix. Methoxy is not suffix, it's prefix like chloro. So I gave this example. So it will be 1,2-dichloroethane. Same thing, it will be 1,2-dimethoxymethane. 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 Now I will give you easier one, Steve. You try this. Same thing. Try this, Steve. Tell me the IU. There is no common name. Tell me the IUPAC name. Steve, try. This is easier. Anyone? Krupa, Rohit?
Auntie, can I try?
Yeah. Try.
Methoxy 1-chloroethane.
See,
2-methoxy.
methoxy will take
Ma'am,
preference
1-chloro
over
2-methoxy-ethane.
methoxy will take preference over chloro while numbering, but while naming, chloro will take the preference because of the alphabetical order. It will be 2-chloro 1-methoxy-ethane. 2-chloro, 1-methoxy. Steve, you are not able to understand. Why? If you're not able to understand, ask. Then only I will know where you are not following. Steve, will you try this? Next one. Try this, Steve. I don't know Steve has any problem with talking or... No, he has not messaged. Steve, will you try this? Okay, okay.
Auntie, is there a common name for this?
No common name. Steve is trying. Got the name, Steve? Tell me however it is, you just message. Let me see.
Ma'am, I know the answer.
Wait. Steve, message. Even if it's wrong, fine. I want you to try. It's okay. We are all learning. We make mistakes. You don't want to try, Steve? You don't know. Okay. Rohit, tell me.
Ma'am, 1-ethoxy pentan for all.
See, this will be, you have to name it nearer to the alcohol. This will take the, it will be an alcohol, definitely. Now tell me.
5-ethoxy pentan to all.
Oh, I have written one next. Okay. 5-ethoxy pentan to all. 2-pentanol. Correct. 5-ethoxy pentan. Now, I will give you aromatic ones. Very important, you have to remember the names, common names of this. Tell me what will be this? Steve, you want
Anisole.
Krupa?
Ma'am, isn't it anisole?
Yes, anisole. Methyl phenyl ether. Actually, it is called as anisole. Methoxybenzene. Methoxybenzene. Similarly, if you have C2H5, what will be the name of this? Ethyl
Ethyl phenyl ether.
ether, that is called as phenetol.
Auntie, everybody left the meeting.
Ayyo. Ethoxybenzene. Ethoxybenzene. I think there is some problem with the internet today. Ethyl phenyl, anisole and phenetol you should know. Should know the common names. Ethoxybenzene.
Auntie, what have you written under ethyl phenyl ether?
Phenetol. Phenetole. Phenetol. online only. With C6H5, it is diphenyl ether. Diphenyl ether, phenoxybenzene. Phenoxybenzene.
Auntie, how diphenyl?
2 C6H5, C6H5. 2 are there. It is C6H5O C6H5. Krupa, try this. Krupa. O CH2. It is little challenging, so I thought you would try this. Try this. It is little challenging, but you can try.
Auntie, above CH, is it CH3?
Yes. CH3, CH3. 2 CH3. What is this group, Krupa? Tell me, what is this group?
2-methyl
No,
propane.
commonly. See, tell me, what is this group?
Isomethane.
Hey, what is this group? How many carbon atoms are there?
3.
Rabbit with bunny ears.
3, Auntie.
Isopropyl, no?
Yes, Auntie.
Isopropyl. This will be isobutyl. This will be isopentyl. Okay.
Yes, Auntie.
So this is that group. It is written like this. It is
Auntie, so will it be like
tell me now.
2-methyl isopropyl?
Isopentyl phenyl ether. Okay, common name. Now tell me the IUPAC name. That is more challenging. This is isopentyl group, ma. This whole thing, I told you how it is, isopentyl.
Auntie, but there are 2 carbon in one single carbon.
Pardon?
There are 2 carbon, Auntie. CH3 and CH3 in one
Ah.
single CH.
Yes.
But still it is isopentyl
Same
only.
thing. This group I have written it like that. That's all. Like instead of writing like this, I have written like this. That's all.
Okay, Auntie.
This is isopropyl, isobutyl, isopentyl.
Got it, Auntie.
Got it. Now tell me the IUPAC name. You don't have a competitor at all. You are alone, so you can answer. I will help you. You number
Auntie,
it like this. Now tell me.
Auntie, will it be 3-methyl propyl phenoxybenzene?
No. Just listen here. Just listen. Now, what this group? What will be this group?
Propoxy ether?
How many carbon atoms are there? Count.
4.
4. So what will be this group? If there are 4, what is the root word?
Propene.
4.
Butane.
So what will be the name of this?
Butoxy ether?
Butoxy, correct? Butoxy, correct?
Yes, auntie.
1 butoxy if I link something over here. Now, instead of that, I will have a methyl group here. Now tell me.
3 butoxy.
Eh,
No, it will be 3 pentoxy.
see, without this, it is 1. See, where it is joined, you have to give that number.
Okay, auntie. Then it will be
I'm not
3
changing that
methyl,
one.
1
Ah,
butoxy.
1 butoxy, I am not changing. I am just replacing here 1 methyl.
3 methyl,
Ah,
1 butoxy.
correct. 3 methyl, 1 butoxy. This whole is one group. So put it like this, benzene. That's all. Okay?
Yes, auntie.
Okay. Last one, we'll finish it off with this and then start with the preparation. Now tell me.
Auntie, should we use ortho?
No. Just number it. Number it is a derivative of hexane. Number it. Here it will be 1, 2. Now tell me, it's easier now.
Auntie, common name will be dimethyl.
Hmm. One
Dimethyl ethyl
1
phenyl ether.
dimethyl cyclohexyl ethyl 1 dimethyl cyclohexyl ether.
Auntie, can you repeat it?
1 dimethyl cyclohexyl ether.
Okay, auntie.
Okay, but what will be the IUPAC name? You have ethoxy and dimethyl. So which will come first?
Ethoxy.
2-ethoxy 1,1-dimethyl cyclohexene. That's it.
Auntie, can you write the common name?
Huh?
Common name.
Common name, it will be ethyl. But if you write the common name, then this will come. This will only come for 1. 2,2-dimethyl cyclohexyl ether. You can't give the number. This has to be numbered 1 because you are linking this ethoxy. Okay, so it will be ethyl, then it becomes 2,2 dimethyl cyclohexyl ether. This will be 1, this will be 2. Ethyl 2,2-dimethyl cyclohexyl ether.
Yes, auntie.
But you will have to write the, that will be the common. Okay. Now we will learn the preparation. Preparation, only the equations you can write. We will write I will send you the notes. Okay. Now, we know that very important reaction, ethyl alcohol, it will undergo dehydration if you treat it with concentrated H2SO4, protonic acid like phosphoric acid or H2SO4, it will undergo dehydration. I have told you this, at 140 and 170, very important temperatures. If you heat it to 170, it will undergo dehydration to, it will remove a molecule of water to form ethene. At 140 with concentrated sulfuric acid, you are going to get ether. Okay, you are going to get ether. You are going to study the mechanism of this reaction. You are going to study the mechanism of this reaction, how it is done. Okay, so how it is done, I will tell you. You take ethyl alcohol, heat it to 140 degrees centigrade. 140 means 273 plus 140, 413 Kelvin. This will be 443 Kelvin. If they give it, it's very important. They will give the temperatures. If they mention 443, write it as ethene. It will undergo dehydration. If they give it as 413, you will get the ether. Okay. So what happens is that here also it is dehydration, but here two molecules are involved. You take two molecules of ethyl alcohol, you remove water, you are going to get the ether. From the same molecule, if you remove water, you will get ethene. Okay. So actually here, if you observe it carefully, what is happening here is you are replacing that Bharatwaj is calling. 2 minutes. Tell me, Bharatwaj, what happened? Hello? Not able to hear you. Now I can hear. Tell me. Yeah. Yes. Doesn't have the link now. Oh my God. Everybody has a problem. 1 minute, Kripa. I'll just send the link to him. He wants the link. I don't know how to search where is that link. I don't know. Is the link. You have the link, Krupa? Last link?
Yes, Auntie. Should I send it in
Yeah,
the
you put
group?
it in the group, no?
Yes, Auntie. 1 second.
I have just put it in the group. Where to search? Oh no, I don't think I have. No, I don't have it here. I don't think I have it in the. You sent it?
Yes, Auntie.
Thank you. Good job. Okay. So, if you take two molecules and remove water, you are going to get ether. From the same molecule, if you remove water, you are going to get ethene. This will happen at a higher temperature. Concentrated sulfuric acid will take water at a higher temperature to give you this. So, but now we are loving the preparation of ether, so we are interested in this reaction. So, here what is happening is, I will tell you, I will explain the mechanism and then tell you what is happening exactly there. Okay, the mechanism consists of 3 steps. In the first step, you have alcohol and you have a proton. This is from the acid. Acid will ionize it to give a proton. So this will attack this and you are going to get the oxonium ion or the protonated alcohol. You are going to get the protonated alcohol. You can write the mechanism. Okay, you get the protonated alcohol. So, the actual reaction is, it is a nucleophilic substitution bimolecular. Bimolecular. That means it depends on the concentration of both the alcohol and the acid. Okay, so I will tell you how it is a substitution reaction. This is the first step. First step is the protonation. Alcohol, because the lone pair of electrons on oxygen, it will act as a base. It will abstract the proton from the acid, forming the protonated alcohol, oxonium ion. Then what happens? This oxonium ion, see, this is electron deficient, this oxygen. So because this is electron deficient, it pulls the pair of electrons of this bond to this. So this becomes electron deficient now. So when this becomes electron deficient, what happens now is, just okay, now this is electron deficient. Because this is electron deficient, it pulls the pair of electrons of this bond. So this becomes electron deficient. Now this will attack this now. When this attacks this, this is removed as water. This is the RDS. That is, this is the rate determining step. So this will, what happens is that it will become like this. That means you are removing this. This will attach to this. CH2, CH3 one side, CH2, CH3 on other side, this H. This will become like this. This is actually protonated ether. You will have to just remove the proton there. So in the third step, loss of a proton will occur. How it will occur? The alcohol again, it will take back that proton. It will take back that proton to form the ether and the protonated, you can write it directly, and the protonated alcohol. The reaction goes on. So what is happening here is, you are substituting this hydrogen by C2H5 group. So it is called as a nucleophilic substitution reaction. Since it depends on the concentrations of both the alcohol and the acid, it is bimolecular. So how it happens? It happens by the attack of, first it gets protonated and the alcohol molecule attacks the protonated alcohol, forming protonated ether. That protonated ether loses a proton, then forming the ether and protonated alcohol. So the reaction is substitution nucleophilic bimolecular and occurs by the attack of the alcohol molecule on the protonated alcohol. You will get the ether. Okay. Now, very important thing here is, see, ether, though it is small, there are so many questions, even in the book back. You can see so many questions. So, especially this at the next reaction. See, for this reaction to occur, this carbon should be approachable. That means there should be no steric hindrance to the attack of this carbon. That can happen if the alcohol is a primary one. This alkyl group is a primary alkyl group. If it is secondary or tertiary, because of the stereochemistry, this carbon gets hindered. There will be steric hindrance, and this oxygen will not be able to approach this. When this is not able to approach this, it ends in elimination rather than substitution. Always in ethers, remember, there is a competition between elimination and substitution. If it is primary, it is always substitution. If it is tertiary, it is always elimination. Tertiary, you cannot substitute. I will tell you, because it will be so bulky that it cannot attack that. So if it is tertiary, it is always elimination. If it is primary, it is substitution. If it is secondary, it depends on the conditions. Whether this reaction occurs at a low temperature. Temperature should be low. If it is high, it becomes elimination. So for secondary, temperature plays a very important role. Okay, write down the mechanism. Mechanism, just write the steps. I'll tell you give you the explanation later. This is the slow and the rate determining step. So first step, protonation of the alcohol, then attack of the alcohol on the protonated alcohol to give you protonated ether, then loss of a proton forming the ether. Write down this. If it is secondary or tertiary, they will immediately lose a molecule of water. They will immediately lose a molecule of water, forming stable 2 degree and 3 degree carbocations, which will lose a proton and form the alkene. So attack is difficult. That is why it will lose a molecule of water. So this method is useful for preparing ethers having primary alkyl groups, and temperature should be low. It should be unhindered. Over? Just write down the
Yes, Auntie.
just write down the equations, then you can Next reaction is more important and which you have studied already. That is the Williamson's ether synthesis. What is the reaction? Where did you study? Where did you study this? And what is the reaction?
We studied this in ethers thing starting.
Ether preparation, man. In which chapter you studied this? You don't remember? You take an alkyl halide, treat it with sodium alkoxide, NaOR dash. I told you this in halolkenes. You are going to get an ether. Williamson's ether, very important reaction. When an alkyl halide reacts with sodium alkoxide, this is sodium alkoxide. You remove molecule of sodium halide to form the ether. How do you get sodium alkoxide? Treat sodium with an alcohol, you will get sodium alkoxide. Now, see, in the first method, that is the dehydration, if you use ethyl alcohol, you are going to get diethyl ether only. That means you are going to get symmetrical ethers only. You cannot prepare unsymmetrical ethers because same molecule is reacting. So, this method, if they give you to give a method to prepare ether, if it is symmetric, you can use dehydration. But if it is unsymmetric means different, both the groups attached to oxygen are different, you cannot use the dehydration method. Then what you will do? You will use Williamson's ether synthesis method. That means if you want unsymmetrical, for example, I take this to be CH3Br and this I can take it as C2H5ONA. Then I can remove this and I am going to get ethyl methyl ether. So anything I can prepare, that is symmetric or unsymmetric, this method is suitable. You can prepare both the methods. Okay, but this is also not that easy. What happens in this is that the sodium alkoxide what happens here? So because of the inductive effect, this will develop a negative charge and this will develop a partial charge, partial positive charge. When this develops a partial positive charge, the pair of electrons on oxygen will attack this and you remove this. When you remove this, you are going to get C2H5O, CH3 and NABR. Okay. Here also, it is an SN2 reaction, substitution nucleophilic bimolecular, because the attack and the breakage takes place simultaneously. It takes place in a single step. So it is bimolecular. And you know that SN2 reactions always primary alkyl halides are favored. Primary alkyl halides are favored in SN2. If it is secondary or tertiary, again here elimination is favored. This they will ask you the reactants. I will tell you how to choose it. So the alkyl halide should be primary. Okay, if it is secondary or tertiary, then you will end up with elimination only, not the substitution. What do I mean by that? For example, I have this. This is the in-text question actually. If you have this compound, if you want to prepare this compound, how will you prepare? How will you prepare? There are two choices. One, the tertiary butyl group can give the alkoxide and you can have alkyl halide from the smaller group. From the bigger group, alkoxide, and the smaller group, alkyl. Another choice, from the bigger group, alkyl halide, and from the smaller group, alkoxide. These are the two choices possible. Same question they have asked in text. These are the two choices possible. But the correct reagents are this and not this, because if I use this, I will end up with, I will remove HBr here and I will end up with propene, that is methylpropene, and NaBr and water. You remove HBr here, HBr will react with this forming NaBr and water. So you are going to get here 2-methylpropene and not the ether. So why? Because the alkoxide ions, they are both nucleophiles and bases. They will abstract the proton They will abstract the proton rather than substitution. They prefer elimination rather than this, because it is steric hindrance. Again, it is the steric hindrance. This is more approachable because otherwise it has to attack this carbon. This carbon approach is difficult because of the 3 bulky alkyl groups, whereas elimination from any one of these hydrogens is easier. That is why it will prefer to undergo elimination rather than substitution. So what happens here? What happens here? So you are going to get NaBr, water and CH2OH will get. So if you want to prepare like this, always choose the smaller group with the halide and the bigger group with the alkoxide. Then only you will get the substitution. That is the ether you get. If you take the reverse, you will end up with elimination. This only they will catch you. They will ask you to choose. So Williamson's ether synthesis limitation is this. They have asked the limitation in the book back. 2 limitations. I will tell you the second one. What is the first limitation? First limitation is that you can prepare symmetric and unsymmetrical ethers. But the problem is choice of the reactants. The alkyl halide should be primary. Alkoxide can be primary, secondary or tertiary. Anything is okay. But alkyl halide should be primary. If you take the reverse, you will end up in elimination. That is one of the limitations. So this is Williamson's ether synthesis. Now, why this is happening? This is also SN2. As I told you, both occurs at the same time. Now you can prepare, see, for example, you can prepare that is anisole and phenetone. How you can prepare? You take the sodium phenoxide and treat it with this. Then what will happen? You remove NaBr and it will attack there and you are going to get anisole. You can use this to prepare alkyl aryl ethers, but you cannot use this to prepare diaryl ethers. That is the other limitation. Why? Because if you have another like this, you have to remove this. This has to break. You are breaking this. This breaking is easier than this breaking of this bond. Because of the resonance conjugation, this will have a partial double bond character. It is not easier to break this bond. So this method cannot be used to prepare diaryl ethers. You cannot prepare diaryl ethers using Williamson's ether synthesis because it involves the breaking of this bond, carbon halide bond, which is difficult in aryl halides. That is the second limitation. First limitation is choice of the reactants. Or alkyl halide should be primary and this one can be anything, alkoxide. Second limitation is you cannot prepare diaryl ethers with this because you cannot break this bond easily. Those two are the limitations of Williamson's. Write down this, Krupa. You just write down this reaction. That's enough. I am going to discuss this in text. So just write down this. You are going to get anisole. Okay?
Yes, Auntie.
Same thing they have asked in this in-text question. What is the in-text question? Write down this. C2H5ONA plus CH3 CH3, CH3, Cl will give you, write down this, they will given this, CH3, 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 OC2H5. They have given this example question. Okay?
Auntie, the board is blurred, Auntie.
Huh?
Now it's fine, Auntie. The board was blurred, Auntie.
Board is blood. I'll read it out. C2H5ONA, C2H5ONA plus, you write tertiary butyl chloride, CH3, 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 CCl, CH3 3Cl, tertiary butyl chloride. Then arrow, you write tertiary butyl group and OC2H5. Tertiary butyl, ethyl ether.
Done, Auntie.
Okay. Now, they have asked two questions. What would be the major product of this reaction? What will be the major product of this reaction? Will you get ether here?
Yes, Auntie.
Tell me, see that and tell me properly. You are taking the tertiary butyl halide. If the alkyl halide is tertiary, you will not get the ether.
Auntie, your voice is
Elimination.
breaking.
So, the product formed here will not be ether. It will be this product, 2-methylpropene. Okay? It will end up in elimination because alkyl halide is tertiary. So, if I want to prepare this, what will be the reactants I have to use? What will be the reactants I have to use if I want to prepare this?
Auntie, I'm not able to hear you.
You are not able to hear me?
Auntie, your voice is breaking.
Okay, I am asking if I want to prepare tertiary butyl ethyl ether, what should be the reactants? Could you hear now?
Auntie, can you tell me the question number? I will see the textbook, Auntie.
11.6. See the textbook? 11.6. Got it?
Yes, Auntie.
Okay. So, if you take tertiary butyl halide and primary alkyl with alkoxide, sodium alkoxide, you won't get the ether. You will end up in elimination. You will get the alkene. So,
Auntie, what is the question, Auntie? Can you repeat the question?
the question is, what would be the major product of this? First question. Second,
Auntie, there is no such question in the textbook.
it's there.
In text or example, Auntie?
Example. Got it?
Oh, yes, Auntie.
Got example.
Yes, Auntie.
Okay. So, if you want the ether, always take the smaller alkyl group with the halogen, alkyl halide. And the other one, take the sodium alkoxide. Tertiary with the sodium alkoxide. Then you will get the ether. But if you take the reverse like this, you will not get the ether, you will get the eliminated product. Understood, Krupa?
Yes, auntie.
Okay. So, we will do more examples later. Even in the properties, we are going to do this. Okay. So, next I will just finish the physical properties. Chemical properties, I will do it in the next class because it's a continuation. Next class, I will finish off ethers. Okay. Not many properties are there. Only one property in detail you are going to study that. The rest is very easy. You can just finish it off. And then the in text and example, all the questions. Next class we will finish off ethers. No problem at all. Okay. So,
Okay, auntie.
physical properties, because ether is not reactive. The oxygen is not reactive there. Okay. So, it has got very low polarity. Okay. It has got low polarity. That is why it doesn't form any extensive hydrogen bonding. Because of that, it has got low boiling point. Actually, ether bottle, if you keep it open, it will evaporate. Very low compared to isomeric alcohols. Okay, alcohols will have higher boiling point because of hydrogen bonding. Okay, and ethers, they are soluble in water, but the solubility decreases as you increase the alkyl. Bigger alkyl groups will become less soluble. Okay, they will still mask the oxygen atom, so they are less soluble. They are more soluble in organic solvents like acetone or benzene, carbon tetrachloride, all that. Okay, they have got low boiling point because of no association, no intermolecular hydrogen bonding. 2, their solubility, they are soluble in water. That means lower members are soluble in water, but higher members are not soluble because of the increase in the bulkiness of the alkyl. Okay, so only those two physical properties, and chemical properties I have to discuss in detail because you are going to cleave. Again, there is a problem. When you cleave also, bigger group will take what and smaller group will take what. That is a computation. So I will have to discuss that in detail with the mechanism. So that will take a long time. So I will do it in the next class.
Yes, auntie.
Okay. Now, okay, ma. Okay, Kripa. Bye. I'll upload this one because so many of them were absent today.
Yes, auntie.